Okay, hey guys, it's Melina. In this week's video, we're going to be talking about molecular orbital diagrams and how to draw them with conjugated systems. Here. Okay, so this is a conjugated diene. This is the structure we're going to be that we're going to be using. So in this structure, you have how many electrons for the p orbitals. So we have 2 pi bonds, and for each pi bond, we have 2 electrons filling those orbitals. So we're going to have a total of 4 electrons for the atomic orbitals. And with the atomic orbitals, however many atomic orbitals you have is how many molecular orbitals you're going to have. So we have 4, so on 4 atomic orbitals, so on the right side, we're going to have 4 molecular orbitals. And within the molecular orbitals, you're going to have bonding and anti-bonding. Bonding is a stabilizing reaction, so they're going to be lower in energy than the atomic orbitals. That's depicted in pi 1 and pi 2. In this class, we don't use pi to depict the energy levels, but that's just what this diagram is showing. So just energy level like 1 and 2. And then as you can see above the dotted line, we have 3 and 4, and these all have stars next to it. These are the anti-bonding orbitals, and anti-bonding orbitals are higher in energy than the atomic orbitals. So next, what we're going to do is draw out the depiction. We're going to depict the p orbitals. So we have 4 because these all represent each carbon in the structure that has a p orbital, right? So 1, 2, 3, 4. 1, 2, 3, 4. These are the p orbitals. So we're going to start off at the lowest energy level, and that energy level is going to have all the p orbitals in phase. They're all going to be overlapping. So that is depicted right here. See, all the shading is on one side, right? This is called like in phase, but it just means they're overlapping, just like right here, right? All the red overlaps and then all the blue overlaps. As you increase your energy levels and you increase going up, you're going to add in 1 node. And what a node does is it disrupts the overlap of the p orbitals. See right here, it's switched and they don't overlap right here. So it doesn't matter if you start, like, see how we start on the top here and here we start on the bottom. That's not really important, but just as long as when you hit a node, you have to change. So here we start on the bottom, 1, 2, and then we hit a node. So now we have to go to the top, right? So that's the same thing here. So we start red, 1, 2, we hit a node, and then the red goes on the top. So now we're going to increase another level. So we're going to add in an additional node. And when we add in nodes, we have to do it with some type of symmetry. See, for this one, it's just in half. And then this one, they did some type of symmetry. You can kind of see it. It's not always going to be perfect, but you'll get used to it. So we start here on the bottom, we hit a node, and then we go on the top, and then we hit another node. So we're going to go on the bottom. And for the last one, we're going to add in an additional node. So there's a node in between all of the orbitals. So it's bottom, node, top, node, bottom, node, top. So these are what all the p orbitals look like. And the more nodes you add in, the more destabilized it is. So the bottom one is the most stabilized. Also, you can see that it's the lowest in energy. Remember that the lowest in energy is always the most stable. So now, after depicting what the p orbitals look like, we have to fill in the electrons for the molecular orbitals. So remember over here, we have 4. So we have 4 electrons to work with. And remember from Gen Chem, start from the bottom, fill, and then work your way up. So we have 1, 2, filled, we move up, 3, 4, now we're done. Now we have to determine the HOMO and LUMO. And this is where a lot of people get confused because a lot of people think we're looking at the depiction of the p orbitals, but we're actually looking at the actual electrons. So in the second level, you can, second level from the top, from the bottom, yeah, right here. This is the second level. So this is the highest level filled with electrons. So this is the highest occupied molecular orbital. And right above that, you're going to have no more electrons, right? So this is the lowest unoccupied molecular orbital. So yeah, that's how you draw molecular orbital diagrams for conjugated structures and determining how to figure out the HOMO and the LUMO. So just a couple of key points to remember. The number of atomic orbitals will always equal the number of molecular orbitals. Bonding orbitals are lower in energy than atomic orbitals, and anti-bonding orbitals are higher in energy than atomic orbitals. As you increase one energy level up, you always add in an additional node, and what the nodes do is they disrupt the overlap of the p orbitals. Nodes are added in with symmetry, and you always fill in the electrons from the bottom up. And yeah, oh, and when you're looking for the HOMO and the LUMO, look at where you're actually filling in the electrons, not the depiction of the p orbitals. So yeah, thanks for watching, guys.